Today we are going to be testing some copper that we have that we're going to be separating on the ChromaSort optical sorter. So this here, some copper that we had in that first pass, with that material was mixed with this here. So that was all together. So we were able to get it to where this is the clean fraction, but not clean enough for my test, for my liking. So what we did is we granulated it, which removed all the plastic, and then we're left with this. And this here, you can see, flows through my fingers like sand. And you can see the brass is in here, the pieces of brass. So what we're gonna do is we're gonna put this into the sorter. So this is a really cool system because it uses an algorithm to separate, not just by color, you can choose what gets thrown. So what gets shot. So the nozzles are here. Material comes here and it shoots right around, right over this bar, just barely touches this bar. And then it goes down the trajectory into this section here. The nozzles are right here and they shoot the rejects into this side. And those slide down into this side here and come out this side here. Sort by shape, sort by colors. And I mean, all the way down to dust. Now you could screen some of this, but what happens when you get to a certain size, it gets harder and harder to separate aluminum from copper. Once you get down to small particles that are similar in shape, because the air, especially if you've used a turbo mill, the air blows around the aluminum. So like aluminum copper radiators is different because that aluminum flake has surface area, so it's really easy for the air table to just blow that back. It kind of floats on that bed of air. But when you're balling everything down, the air flows around that ball, and then your ball sinks to the bottom and then climbs up with the copper. So